This is Bob Capetta from the University of Illinois at Chicago, and this is Math 121 Pre-Calculus Final Exam Review, Part 2, Problems 5 through 10. First question is to prove that sine x times cosecant x plus tangent squared x equals 1 over cosine squared x. I like to start with one side of the identity and then have a string of equals to equal the other side. So I'm going to begin with the left-hand side. So the left-hand side is sine x times cosecant x plus tangent squared x. But cosecant x is 1 over sine x. So we get sine x times 1 over sine x plus tangent squared. Sine x times 1 over sine x is, of course, just 1. We get 1 plus tangent squared. And that is one of our Pythagorean identities. We have 3 Pythagorean identities. The first one is cos squared x plus sine squared x is 1. The second one is 1 plus tan squared x is secant squared x, and the third one is cotan squared x plus 1 is cosecant squared x. But what is secant squared x? That, of course, is just 1 over cosine squared x, and that equals the right-hand side. So this is my preferred way of proving identities. Start with one side, in this case left-hand side, equals right-hand side. That's my preferred way to prove an identity. Next example, we want to prove sine 2x plus sine 4x over cos 2x plus cos 4x equals the tangent of 3x. To do this, we are going to need some identities. So the sum to product identities, sine A plus sine B is 2, sine A plus B over 2, cos A minus B over 2. And cos A plus cos B is 2 cos A plus B over 2, cos A minus B over 2. Why do we know those are the identities we need? We'll notice sine 2x plus sine 4x matches this. Cos 2x plus cos 4x matches that. So we're going to have to do our substitution. A is going to be 2x, B is going to be 4x in the first equation. A is 2x, B is 4x in the second. Easy for us to keep in mind. So sine 2x plus sine 4x will be 2 sine 2x plus 4x over 2, cos 2x minus 4x over 2. 2x plus 4x is 6x, divided by 2 is 3x. 2x minus 4x, negative 2x over 2, negative x. Cos of negative x is the same as cosine x. Cosine is an even function. Sine of negative x is negative sine x if that comes up. We can simplify that numerator to be 2 sine 3x cos x. Denominator, we have cos 2x plus cos 4x. We're going to use the second identity. That'll be 2 cos 2x plus 4x over 2. Cos 2x minus 4x over 2. Cos 6x over 2 is cos 3x. 2x minus 4x, negative 2x over 2, cos negative x. And again, cos of negative x is the same as cos x. So we recognize that this numerator can be replaced with 2 sine 3x cos x. The denominator can be replaced with 2 cos 3x cos x. So now let's go ahead and do our proof. Start with the left-hand side, a bunch of equals to equal the right-hand side. Left-hand side is this. And then the work we did on the previous page, 2 sine 3x cos x over 2 cos 3x cos x. You'll notice the cos x's cancel. And the 2's cancel. So we get sine 3x over cos 3x, which of course is just tan 3x. And that equals the right-hand side. So again, you see the process. Start with the left-hand side, equals right-hand side, and the identity is proven. Next, I want to prove cos of A plus B over cos A sine B equals cotan B minus tangent of A. So left-hand side is cos A plus B over cos A sine B. Now, what is cos A plus B? Cos A cos B minus sine A sine B. One of our identities, the identity of cos of A plus B. Now we're going to break this up into 2 fractions. The top over the bottom minus the top over the bottom. So cos A cos B over cos A sine B minus sine A sine B over cos A sine B. And then you'll notice the cos A's go away and I get cos B over sine B, which is just cotangent B. Over on this side, the sine B's go away and we get sine A over cos A, which is tangent A. So cotangent B minus tangent A, which of course is the right-hand side. And that is proven. Next, we want cosine of 3 pi over 2 minus theta equals negative sine theta. And of course, we need to have a rule to help us do this. Cos A minus B is cos A cos B plus sine A sine B. So A will be 3 pi over 2 and B will be theta. So the left-hand side again, cos 3 pi over 2 minus theta, cos 3 pi over 2 cos theta plus sine 3 pi over 2 sine theta. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So 0 times cos theta plus negative 1 times sine theta. 0 minus sine theta, just negative sine theta, which is what we're going for. That, of course, is our right-hand side. Starting with the left-hand side, equals right-hand side, and that is a proof. Next, I have secant theta is 3/2, and theta is between 3 pi over 2 and 2 pi, which means theta is in quadrant 4. So let's keep that in mind, and let's answer some questions about that. If I know secant of theta is 3/2, that means cosine of theta is 2/3. Then I can use my fundamental identity to find out what sine is, namely cos squared theta plus sine squared theta is 1. So 2/3 squared plus sine squared theta is 1. 4/9 plus sine squared. 1 is 9/9, minus 4/9 is 5/9. So sine theta is plus or minus root 5 over root 9 or root 5 over 3, except we see theta is in quadrant 4. If theta is in quadrant 4, sine is negative. So indeed, sine of theta is negative root 5/9, negative root 5 over 3. So I know cos, and I know sine, and I know the quadrant I'm in. That's enough for me to answer a bunch of questions. So here we go. There's sine, there's theta. Theta is in quadrant 4. I want sine of 2 theta. Sine of 2 theta is 2 times sine theta times cosine theta. So sine of 2 theta would be 2 times negative root 5 over 3 times 2 over 3. Numerators, 2 times 2 is 4, times negative root 5, negative 4 root 5 over 3 times 3 is 9. So that's our value for sine 2 theta. Next up, what are we looking for? Cos 2 theta. And our identity for cos 2 theta that we'll use is cos squared theta minus sine squared theta. Cos theta is 2/3, square that, minus sine squared theta. Sine theta is negative root 5 over 3. Square that. 2/3 squared is 4/9. This thing squared is 5/9. We get 4/9 minus 5/9, which will give us cos 2 theta is negative 1/9. Next, we're going to look for sine of pi over 6 plus theta. Well, what do we need for that? We need this rule. Sine of a plus b is sine a cos b plus cos a sine b, where a is pi over 6 and b is theta. So you'll notice sine a, sine pi over 6, cos theta, plus cos pi over 6 sine theta. Sine of pi over 6 is 1/2. Cos of pi over 6 is root 3 over 2. But we also know that cos theta is 2/3 and sine theta is negative root 5 over 3. So we can make those substitutions. So 1/2 cos is 1/2 2/3. Root 3 over 2 times sine, root 3 over 2 times negative root 5 over 3. Let's look at our arithmetic here. 2/6 to keep a common denominator here, negative root 15 over 6 there, which we can get ourselves a common denominator and make that 2 minus root 15 over 6 for our answer for sine of pi over 6 plus theta. Next, I'm looking for tangent of theta over 2, and we have several identities for that. I'm choosing to use 1 minus cos theta over sine theta. So it'll be 1 minus 2/3 over negative root 5 over 3. Well, 1 minus 2/3, 3/3 minus 2/3 is just 1/3. So if I multiply the top by 3, I get 1. I multiply the bottom by 3, I get negative root 5. So it's just negative 1 over root 5, however you want to do that fraction division for tangent of theta over 2. You could rationalize the denominator and say negative root 5 over 5. I don't really think it adds much to the problem. Next, we're told 70 feet from a building, the angle of elevation to the top of the building is 60 degrees. So this is the building. There's our angle of elevation is 60 degrees. We want to find out how tall is that building. I'm calling that height. Angle of elevation is 60. There's the height, and you're 70 feet from the base of the building. So opposite over adjacent is tangent. So we'll argue the tangent of theta, tangent of 60, is height over 70. Well, what is the tangent of 60? Sine of 60, root 3 over 2, over cos of 60 over half. Root 3 over 2 over half is just root 3. So we get 70 times tangent 60, or 70 times root 3 will be the height of that building. Next up, we have a 13-foot ramp is used to load a truck. So here's our truck. There is the bed of the truck. It's 5 feet off the ground. Here's our 13-foot ramp. We're asked to label the angle theta that the ramp makes with the ground. There it is. We want to find all 6 trig functions. 5 feet off the ground, 13-foot ramp. We want to find x. We can find that with Pythagoras. So there's x. X squared plus 5 squared is 13 squared. X squared plus 25 is 169. X squared is 144. X is 12. So this is 12 feet, 5 feet, 13 feet. We have enough to answer all of the questions using the trigonometry. So sine is opposite over hypotenuse, 5 feet over 13 feet, 5/13 for sine. Cosine is adjacent over hypotenuse, 12/15 over 13 feet, 12/13. Tangent is opposite over adjacent, opposite over adjacent, 5 feet over 12 feet, 5/12. Cosecant is reciprocal of sine, so reciprocal of 5/13 is 13/5. Secant reciprocal of cosine, reciprocal of 12/13 is 13/12. Cotangent reciprocal of tangent, reciprocal of 5/12 is 12/5. Now what about theta? I mean, there's 6 different ways you could define theta. I'm going to look at the first piece. Sine of theta is 5/13, so theta is just the inverse sine. The arc sine of 5/13 will be the angle theta. Next, we want to find the distance from the person to the boat. Person to the boat. That's a helicopter. So the person to the boat is question mark. We're going to do this with law of sines. How am I going to do that? We'll see 265 divided by sine 48 is question mark divided by sine 59. Cross multiplying 265 times sine 59 is question mark times sine 48. Or multiply both sides by the common denominator of sine 48 times sine 59 if you prefer a more sophisticated approach, and you'll get to this point. Now to solve for the question mark, divide both sides by sine of 48 degrees. And we get the question mark is 265 times sine of 59 degrees divided by sine of 48 degrees. That is the exact answer for the distance from the person to the boat in terms of feet. And the next question we have is to find the length of the tunnel. So you'll notice I have side, angle, side. If you have 2 sides and an included angle, you have to use law of cosines. There's 3 versions. The one that's easiest to remember is c squared equals a squared plus b squared minus 2ab cos c. But you'll notice a is the angle that's given here, so I'm going to use a squared equals b squared plus c squared minus 2bc cos a. A is 300 feet. A is what we're looking for. That's the length. B is 300 feet and C is 200 feet, and the angle A is 80 degrees. So you'll see L squared is 300 feet squared plus B squared 200 feet squared minus 2BC minus 300 times cos of 80. A little bit of simplification here. 300 squared, 300 is 900, 90,000. 200 times 200, 4 with 4 zeros, 40,000. 2 times 300 times 200 is 120,000 cos 80 degrees. 90,000 and 40,000, of course, is 130,000. So if I want to solve for L, let's take the square root of both sides, and we get L is the square root of 130,000 minus 120,000 cos 80 degrees. And that will conclude this lesson.